All right, so our third strategy, I better have that on the recording, is fraction combining. And you'll see what I mean when we get there. But for now, let's just go ahead and do what we already know. We already know we want to change everything into sine and cosine. Now, for you seniors, what that weren't here yesterday, or other people who weren't here yesterday, what do I mean by that? Well, look at that big sheet that I gave you. Find where it says cosecant. What does it say cosecant is equal to? It says it's 1 over sine. So I'm going to change this to sine. 1 over sine. Okay? But this one, I'm not going to change it because it's already sine. We want everything to be sine or cosine. Why is this a good first step to have? Well, remember, our goal is to try to get the two sides to be the same, right? So if I have both sides having the same kind of trig ratio, then that's a good step in the right direction, right? So now I've got the left side has been transformed. Over here I've got sine already, so nothing needs to change over here. But I did talk about this square means that you're taking the sine of x and you're squaring it. But what you don't want to do is you don't ever want to write like this, sine of x. That is not the same thing as this. We talked about that yesterday. This means you're squaring the entire thing. This means you're just squaring the x. Those are different things. And so, but since we are usually, we're familiar with and used to putting the square at the end of what we're squaring, so to fix it, I rewrite it like that. You don't have to do that. I just do that for visual appeal. But just be aware of that. All right. So now this is where strategy 3 comes into play. How many fractions do I have on the right side of my equation here? 1. How many do I have on the left side? 2. Okay. The strategy I'm going to share with you is combining the two fractions on the left, and that's it. Okay. And none of these strategies are like, oh my gosh, a new math idea. They're just really showing you algebra with trig in it. That's all it is. All right. So we're going to combine the fractions. Now, in order to combine fractions, what do we need? You need a common denominator, right? So let's do that. What am I going to multiply the fraction on the left by? The one on the left.
Oh, 1.
You can, right? We don't have to multiply by 1 because that's not going to do anything, but I'll just write it for visual appeal. What do I need to multiply this fraction over here by?
That's sine.
That one we're going to multiply by sine, right? And let's see what we get as a result. So here I've got 1 over sine x plus what?
Sine x squared over sine x.
There we go. And now they have that common denominator, which means I can do what with them?
Add them together.
We can actually put them together as one fraction. And as you guys can see at that point, I now have the two sides equal to each other. And we're done. The goal, remember, is to prove that the two sides are equal to each other. And we've done that. So, once again, we always start off with strategy 1, changing everything to sine and cosine. And we learned 2 other strategies. Now, the other 2 strategies, they don't always happen. How do you know when they're going to happen? Well, the complex fraction strategy, that happens when you see a complex fraction. How do you know when to do this one? Well, this strategy is going to be whenever you have one fraction on one side and 2 on the other. That means you need to combine them together. Okay. Once again, the way I'm showing you guys to do this is not the only way to do them. It's just a nice streamlined process that kind of gets you to know how to do almost any of them. There could be faster and maybe even better ways, but those tend to be only working in specific circumstances. So this one's a little more general, but feel free to be creative if you're feeling confident. Can I erase? All right, so we'll let you guys try a combining fraction problem now. 4. All right. So what I would have you guys do is number 3. Do number 3. We're not going to do any of the other ones right now. Just number 3. Okay, so we're going to change secant squared into 1 over cosine is squared. Now, I'm skipping some steps when I do this, because really, the first thing I'm doing is I'm rewriting it like this. The next thing I'm doing is I'm writing it like this because of the identity. And then I'm squaring the top and the bottom separately, and I end up with what I wrote. But instead of going through that process every time, I'm just jumping right to what I know it's going to be. All right, but I'm showing that in case you didn't understand. So this side already has all the stuff that we like, cosines. So we're going to leave it alone. Now this is where a lot of people were getting kind of stuck. So let's see how that's looking. Sydney, what do we do now? Okay, multiply what? Good. So over here, I would say maybe start off by thinking that as 1 over 1, right? And the common denominator is what? Yeah. So I'm just going to multiply this side over here by cosine of x squared. But whatever you do to the bottom, you have to do to the top, right? And so the result of that, you can multiply this side over here by 1. You don't really need to because 1 doesn't change anything, but just for visual appeal, we'll do it. So what I'm left with then as a result of that is cosine of x squared over cosine of x squared plus 1 over cosine of x squared. And then since they have a common denominator, I should ask Justin, what's the next step? Just combine those fractions together. And this now matches the other side. The top is backwards, though. Does that matter? It doesn't matter if the tops are backwards because why? We're adding. If it's subtraction, that matters. But with addition, it doesn't. So we're good. All right. So that's our third strategy, and that wraps up our lesson from yesterday. So I'm gonna, yeah, that was yesterday's third strategy that we didn't get to, and because I never know how long it's going to take. We're going to move on to our next one. So put those notes away and get out a fresh sheet of paper for lesson 2. Yeah, what's that?
It was already a whole lesson.
Oh,
No,
you
it's good.
kind of, right? Right. We are. It's blasphemy in the middle of the day, right?
What about number 4, though? Strat 4.
That's today. That's the lesson 2 is strategy 4.
So it's a whole nother lesson?
Yes, yes. And I know that's weird to you guys, but it just makes my grading life a little bit easier if things are already broken apart in the way that I've pre-planned them.
Is that the only reason, or is it actually way hard?
Yeah, it's always good a good time to take a break, right? No.
Wait, what? Do you have a that? Did you have a test on Monday?
And I always give you a review beforehand. So here we go. We're going to talk about a fourth identity today, and this one is not something that you already know either, so we'll kind of share it with you. It's called the Pythagorean identity, and it serves the same purpose. You know, it's to simplify an expression, and it can be used to solve equations. So. Before we do, I'm going to write this. Now, you don't need to write this. You can. I'm not going to test you on it, but what it is, it's a proof of the identity that I'm about ready to share with you. Okay? So if you're a math person, you'd like to know why things come from where they come from, then you can write it. If not, you just want to watch, that's cool. All right, so this is a right triangle. And anytime you have a right triangle, you can do Pythagorean's theorem. So what would Pythagorean's theorem be for this triangle? And 1 squared is just 1, right? All right. Now we also remember from unit 10 that x is equal to what? Cosine. And y is equal to sine. So for any angle, cosine squared plus sine squared, that angle will always equal 1. Okay? So this is an identity. That means anytime I see this, I can replace that whole thing with 1. Now it can also be written a little bit differently. Maybe I could subtract sine on both sides. You agree it would look like this, right? That's another one. So if you see this, for instance, then you can replace that with this, something a little bit simpler to look at. And of course it goes the other way. Instead of subtracting sine, we could subtract the cosine on both sides, and we can end up with the opposite of that. There's actually other ways we can kind of, hello.
Okay, that's okay. Super quick.
Right now, the computer lab busy.
Oh, it's not good.
Sorry, but
Okay.
all right. So anyway, so once again, if you see this, then we can replace it with this. And like I said, there's other versions of this as well, and I think I put them all in the handout that I gave you. Let me see. Yeah. So you guys see the first column there, where it says Pythagorean Identities. You should see something that looks like this, right? But there's 2 other columns. Now I'm not going to be teaching you with those. Okay, so once again, if you wanted to, you could put an X through those, because I won't be using them. But for those of you guys that want to look for other creative ways to get those 2 sides to match, those work. So for instance, on your guys' paper, you see, it'll say you're doing a problem, and somewhere along the way you see this. Instead of changing this to sine and cosine, you could just replace it right away with this, right? So you can do that if you want to and be creative. I won't be using those, but you can if you want to get creative. So I gave them to you in case you want to, but for the most part, we won't be doing that. So let me show you guys how these can be used. Go ahead and write down example 1. All right. So here we go. Let's continue. So we're always doing strategy 1 first. So I'm going to start by replacing cotangent with cosine over sine. I'm going to replace tangent with sine over cosine. This side is fine. We'll be leaving that alone. Okay. Now to get that common denominator, right? So I've got strategy 1 here, right? Can I just abbreviate this as strategy 1 now? You guys know what I mean by that? Good. And I'm just going to call this one strategy. I think it was 3. Because why am I going to use strategy 3? Because I've got how many fractions on the left?
2.
And how many on the right? That means I'm going to combine them, right? So that they can match. So if I'm going to apply strategy 3, I need a common denominator. What am I going to multiply the left fraction by? Cosine. And what am I going to multiply the right fraction by?
Oh, I knew that.
So we're going to put cosine x on this side. And we're going to put sine x on this side. And what's cosine times cosine?
Cosine squared.
Good. And sine times sine is sine squared, right?
Yes.
Oh. That looks familiar. Maybe. I don't know. We'll see. All right, now what do I do?
I don't know.
Well, we just got a common denominator.
You add them.
Huh?
Add them.
You're right. So we're going to add the top two together, right? So that's going to be cosine of x squared plus sine of x squared, right? I reversed the order on the left of the denominator, but it doesn't matter because once again, with multiplication, you can do that. It's okay. All right, and here's the golden moment. Justin's already noticed it. What is cosine squared plus sine squared? What can I replace this with? Look at your Pythagorean identities. It's 1.
It's 1.
So I can just replace that whole thing up there with 1. And now I've got my sides equal to each other.
Bro, that's too much.
So wait, where do you get 1 from?
The big sheet,
Cosine
look at your
and
big sheet,
sine.
look at Pythagorean identities, and then look for where it says sine squared plus cosine squared.
That's a lot.
Oh, okay.
Okay?
That is a lot of stiff.
Yeah, I guess so.
We're gonna have that on our test right after too.
And this is a Pythagorean, oh yeah, absolutely. This is a Pythagorean identity, and I'll put in parentheses here strategy 4. Because that's what it is. We'll call it strategy 4. Yeah.
Is this testing multiple choice?
No, that's impossible with these types of questions. You can't make no multiple choice. So
Why not?
you know it just got hard when people start asking that question. Okay, it just got hard. Is this multiple choice? All right. Now, how do you know when you're going to use Pythagorean identities?
You don't.
That is a little bit of a hard call. I would say that, of course, anytime you see cosine plus sine and they're both squared, go for it. Just,
Not always equal one.
yeah.
So,
But the ones that are iffy, you know what? Let's put it this way. If you ever see 1 minus sine or 1 minus cosine, you can replace the other ones. I've lost my pen again. I keep doing this. Here it is. So, so if you see cosine squared plus sine squared, you can replace it with 1. The other thing is, if you ever see this, 1 minus cosine squared, you want to replace it with this. The goal is we want to make things smaller and easier to look at. Okay, so by doing this, it makes it easier. Technically, you could work backwards. If you see this, you could replace it with that. And there may be some benefit to that sometimes, but I'd say for the most part, we're going that way. Okay, because we want to make things simpler looking, not more complicated. All right, so those are our Pythagorean identities. And I have 2 here for you to do. All right, so I want you guys to prove both of those. What do we do first for number 1? Good, so I'm going to replace secant squared x with what? Cool. And then Jennifer, what am I going to replace the tangent with here?
Sine x squared over cosine x squared.
Notice how these both have squares, right, guys? The reason for that is because tangent is being squared, right? And tangent is sine over cosine, right? And so that square goes to both pieces, so they're both squared, all right? Now, we have a nice situation here. We already have a common denominator. So Armando, what do we do at this point?
You multiply. Wait, where are we at? Oh, you just combine like that.
We'll combine the fractions, but yeah. We can't really call them like terms, but I got you. You're going to combine the fractions there. All right. Now, at this point, I think Iman's here today. Brooklyn. Now what? The thingy. That's right. This is a Pythagorean identity. Look at your, for those of you guys who have not finished one yet, take a look at your sheets under Pythagorean identities. On the left column, do you guys see the part that says 1 minus sine x squared? What does it equal? Yep, cosine x squared. And you see now, so that's that. Now what is cosine x squared over cosine x squared? Anytime you divide something by itself, it's 1. And I got the left and right side to be equal.
So why could it just been 1 the first time?
Huh?
It should have just been 1.
Well, technically, you could do that with all of these, right? After you've proven it, then it becomes a new way to rewrite something. So we're just proving them.
You made us do extra work for no reason.
Maybe. Go ahead and write down number 2. Try now. Not everybody's done with 2 yet, so I'll give you a little bit longer for 2. It's exactly the same, but it's a good exercise. So go ahead and do it if you.